Okay. Cosine, funny? Yeah. All right. So you should all have your trig open. Greg. So trig basics. Let's go. So standard position. Angles are created by an arm from the positive x-axis. So we're always starting from here, right? Here's our 0 degrees or 0 radians. That's where we're starting. And then we move into what direction? Counterclockwise, right? Counterclockwise. So this is the initial arm. That's the initial. So sorry, this is our terminal arm. Our initial arm's here. So our terminal arm. And then here's my initial arm right here. Right? Good times? Quadrants. What's this quadrant called? 1. So we have quadrant 1, 2, 3, and 4. Have you heard of CAS before? Oh, good. See, we're doing good. I disagree. Because you have, it's positive, in that quadrant, and everything's negative in this quadrant. Right, just like your angle goes counterclockwise. So you've learned how to convert from degrees to radians, right? So 2 pi equals 1 radian. What is 1 radian? 57.3 degrees. And by definition, what is how do we get a radian? Did you cover this?
Yeah.
When the arc length of your angle is also, equal to the radius. Okay, that is 1 radian. When our arc length is equal to our radius, that angle made is 1 radian. So we like to keep things in terms of x and y. We learned about SOHCAHTOA in grade 10. That was a great time. Super easy, right? SOHCAHTOA opposite over hypotenuse. Yeah?
What's the point of the CSC, SCC, COT?
Okay, we'll talk about that in a second. Okay, so one way to relate our sides, you learned about perms and coms, right? Back when you learned about perms and coms, here's our radius, here's our x, and here's our y. If we want to compare 2 sides at a time, thanks. It's been a long day. I know where y is. I really do, I promise. Okay. Is that better? Okay, I really need you to pay attention today because I might write things like that. Okay, so if we have three different sides, and we want to compare the different ratios of the sides, what are all the ways we can choose 2 sides? 3 choose 2, and that would just be if the order didn't matter, right? Now, what if the order mattered? If we thought that y over x is different than x over y, then we'd be 3 pick 2, and that equals a total of 6 different possible ratios. So there's 6 ways we can compare the sides of a right triangle. You can make it x over y or y over x. You can compare r over x or x over r, or we could do r over y or y over r. There's 6 total ratios. Okay, so we have names for them, right? We call the ratio that does y over x, which ratio? Tan. Yeah, it's a tan ratio of y over x. And so basically we know that x over y is just the reciprocal of your tan. And so those other ratios, so we have y over x is tan. Okay, we have, what else? X over r is cosine. And we have y over r, which is sine. Now we know these are reciprocal, so this is the reciprocal function of sine. Or we give it a special name.
What is that pi?
That gives us, well, the ratios are actually stored in your calculator, right? All the ratios of all the tables. There's actually, we used to use these trig tables.
No, he means like one.
Yeah, so we always use, well, if you wanted to compare, instead of comparing y over r, if we're comparing r to y. Okay?
Like y over r minus
The most common ones we use are sine, cos, and tan,
yeah.
right? And these are just extended. Like cosecant is an extension of sine. You could still use sine to figure it out. And usually when we have this, we change it to a sine, right? We take the reciprocal of it. So we usually stick to these three ratios. And we're trying to further our knowledge of trigonometry. Hey, guess what? We have the reciprocal. It has a special name. Usually you're going to change it back into sine. And we're going to use applications of this when we actually get to the end of chapter 7. Okay? But when we do our problems, yeah, we're probably just going to set them up with sine, cos, and tan. We probably, right? Because those are the most common ones. Why would you could set it up with this guy, but let's stick to what we're comfortable with. Okay? All right, so we know that r is equal to the square root of x squared plus y squared. It's a right triangle. What do we usually have our radius set to? Question, Wiley? Oh, okay. Usually our radius is set to 1 in a unit circle. 1 unit circle. Good old Pythagorean. So coterminal and reference angles. Have you talked about those? Yay. See? You guys know a lot more than you think you do. Okay, so let's talk about each. Two angles that have the same terminal arm are called coterminal. So, if this angle, say, is 120 degrees, give me an example of a coterminal arm, coterminal angle. 360 plus 120 would be, yeah, you could do that negative. You could do negative. Yeah. So around and again would be 200 and, no. Thank you. I can add too. 480 degrees. Okay? Now, what's the reference angle here? Adrian, shh. What's the reference angle? 60. So, our reference angle by definition, guys, it's always an acute angle. What does acute mean? Less than 90. So it's the acute angle from the x-axis. Okay, here's my x-axis. Uh-oh. Uh-oh. What happened to my sensor? There's a little fluff in it. So funny. Okay, so this is our reference angle, which is 60 degrees. It's always the acute angle from our x-axis. Okay, so coterminal angles, how do we get them? So if we want a coterminal angle, I'm going to use, we take our angle in center position, and we can add 2 pi to it or subtract 2 pi. So add 2 pi n, where n is an element of the integers. Are you getting more comfortable with pi? Or are you still kind of like awkward at face? Some of you, yeah. Maybe. Okay, so let's go on. I wasn't around, remember?
Yeah, she wasn't around.
Yeah.
That's in a week from
Next,
yesterday.
yes, week from, I will. Okay, special triangles. So the unit circle is actually built out of special triangles. All right? So the special triangles are the exact same thing as really the unit circle. So how it is that there's only 2 triangles you need to memorize. And you can answer all your questions based on these 2 triangles. Yeah, really. Or you memorize the unit circle. So either way, you're going to memorize something. Adrian, can you move to the front? Thank you. So basically, you just need to memorize this triangle. If you there's two triangles, the 45 and then the 30-60. In a 45, we know this is actually an isosceles triangle. So these two sides, if we call them 1, how do I get this root 2? 1 squared plus 1 squared equals the square root of that gives you root 2. Yeah. So that's the 45-degree triangle. So if I wanted to get, say, tan 45 would be 1 over 1 using your SOHCAHTOA ratios, or just 1. If you wanted to get cos of 45 degrees, well, cos is adjacent over hypotenuse. It would be 1 over root 2, or rationalize that, it's root 2 over 2. Okay? If I wanted sine of 45 degrees, sine is opposite over hypotenuse, so 1 over root 2. Rationalize that is root 2 over 2. If you memorize the 30-60 triangle, the 30-60 triangle, you just have to know, you have to memorize 1 root 3, 2, right? Opposite your 30. Think about it this way. 30 is the smallest angle. And so if you label this 1, 2, 3, 1's the smallest side, hypotenuse will be the biggest, and the root 3 is between, right? It's opposite the 60. So it's not as big as a 90, but it's not as, right? Okay, do you see what you just have to memorize a triangle. So when I make my triangles, and I make my 30 and 60, I know the root 3 is right beside this, so 3, 2, 1. I just draw it. So how is it useful? Okay, if I wanted to find sine 30 degrees, okay, sine of 30, once I know this triangle, sine 30 is opposite over hypotenuse, so it'd be 1 over 2. Opposite over hypotenuse. If I wanted cos of 30 degrees, cos of 30 is what? Adjacent over hypotenuse, so root 3 over 2. If I wanted to figure out tan of 60 degrees, tan is opposite over adjacent, so it would be root 3 over 1. Well, you have to change, so you have to figure out your reference angle to figure out the ratio, right? And if it will be positive or negative. You still have to use CAS, and you have to figure out your ratio. So if it was 120 degrees, I'm going to be working with, okay, if I had 120 degrees, what's my reference angle? 60. So if I was trying to figure out cos of 120 degrees, so using cast, is cos going to be positive or negative? Negative. So it's going to be a negative ratio. And then 60 degrees, cos would be 1 over 2, so negative 1/2. That's it. Okay? So, yes. Why is there 2 cos? Oh, this is supposed to be 60 here. There's two methods to teach it, okay? I'm going to show you the shortcut for the unit circle if you want to memorize the unit circle. So if everyone can just grab a blank piece of paper.
How about I grab my unit circle?
Well, no, we want to make our own really quickly. We're going to make a really quick version.
Why don't we just use our...
I'm going to show you a really easy way to make the unit circle. Make it on the orange here, guys. Make it on the orange, okay? Okay. So we're going to make this very quick. Good old unit circle. Okay, this will help you hopefully. I don't know. Okay, so I can only do so much for you when it comes to your rate. Like, you're going to have some knowledge here. Okay, 1, 2, 3. Okay, so easiest thing is, do you want to start with degrees before we do radians? Or do you like using your radians? Okay, so here, I'm going to use radians. So 0 and 2 pi. Okay, which one's here? Pi over?
Pi over 6, 12. Pi over 6.
Yeah, 6. Pi over 6, then pi over 4. It's a quarter, and this is a third. What's this? Pi over 2, half pi, right? Here's my pi, so it's all about fractions. Now, when I use mine, I like to use the sixes. So we have 1, 6, 2, 6, 3, 6. We're just skipping the 45. So this would be 4, 6, or 2/3. Skip the 45. So we had 4, 6. Now we're at 5, 6. 6 over 6, which is pi. 7 over 6. Skip the 45. Then we're at 8 over 6. What does 8 over 6 reduce to? 4 over 3. 9 over 6, which reduces to 3 pi over 2. 9, 10 pi over 6, which reduces to 5 pi over 3. You still, as far as the angles go, that's not the shortcut I'm showing you. Okay? And then last is we were at 7, 8, 9, 10. 7, 8, 9, 10. This will be 11 pi over 6. Okay? Okay? And then our 45s, pi over 4, 2 pi over 4. We're always using these lines. Then 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. Okay? So that part I don't have a shortcut for. I use the sixes, and then I do the quarters. That's how I work through it. It's a really bad circle. It's so funny. Sorry. Okay. All right. Now, this is my shortcut. Ready? You need to be listening to this. Does everyone have their circles done? No. Okay. Okay. So here's my shortcut. You start at the x-axis always and the x-coordinate. So I don't know if you want to put in your coordinates here, like just the brackets. So we're going to fill in these guys, right? Now, I mean, this guy's easy. What is he? X is equal to 1, y is 0. What's this guy? 0, 1. This guy, -1 and 0. And last, 0, -1. Okay, so those ones are the easy ones. The other guys, here's my shortcut. You start at the x-axis and the x-coordinate. We're starting with the numerator. And you go 3, 2, 1, 3, 2, 1. Okay, so our first step, just wait. You're starting at the x-axis, x-coordinate. You go up from the x-axis, 3, 2, 1, back down, 3, 2, 1. Okay, because you're doing the x and then the y. X and then the y, right? X-coordinate, y-coordinate. Next step is we just divide everything by 2. Put everything over 2. And last is we square root the numerators. All of them. What's the square root of 3? Root 3. What's the square root of 1? 1. So leave it root 2, root 2. Square root of 1 is 1, root 3. Done. Okay? Okay, let's start with this guy now. So again, we're starting at the x-axis, x-coordinate. Now you have to figure out the signs after, but we'll do that last. So starting at the x-axis, the x-coordinate right here. So 3, 2, 1, 3, 2, 1. What's the next step? Divide everybody by 2. And then square root who? The tops. Square root the tops. You really should. So you can make one the fastest. Okay? Now, what do you have to remember in this situation? Oh, gosh, don't ask. Okay, so who's negative? Well, it's xy. So is the x or the y negative here? The x is negative, so all the x's need a negative in front. Okay? Okay, so again, starting at the x-coordinate, x-axis. Always starting up here by the x-axis. Yeah? 3, 2, 1. 3, 2, 1. Divide everybody by 2. Square root your tops. And then figure out who's negative. Who's negative in this quadrant? All of them. Yeah, I bet. Okay. Now you can also use the reflection method, right? You guys talked about the mirrored image. Same idea, right? Once you know one, you technically can get the rest. And last, so when I figure out, sometimes if I use two methods. Sometimes I use the unit circles and sometimes I use special triangles. If I use unit circle in my head, I literally hear myself going 3, 2, 1. Okay, so it's this. Or 3, 2, 1. Like that's how I figure it out. Make your two special triangles and it works for everything.
They work for everything.
Yeah. Okay, so last, starting at the x-coordinate x-axis. 3, 2, 1, 3, 2, 1. Divide everybody by 2. And then square root the tops. Who's negative here? The y. Okay? Hopefully that helped.
That helped a little bit.
Yeah? Okay, so.
Okay, so wait, like the pi over 6, that's the angle.
Yes, that's the angle. That's 30 degrees. So this is also 30 degrees, 45, 60, 90. Right? This would be our 120, 135, and 150. Thank you. 180. Good to, I like to put my angles inside, my degrees inside. But it's up to you. Okay? All right, so going back. To our notes. I'm not going to show you the chart. Honestly, it's not worth it. And one more thing I didn't mention. Who's your x-coordinate, cos or sine? Yeah, it's cos because your radius is 1, and cos is equal to x over r. So x over 1 is just x. So cos comma sine. How do we get tangent? Sine over cos, y over x. Yeah, sine over cos. Okay, now if you use if you use special triangles, you don't have to do the y over x idea, right? You're not using you just go straight to your triangle.
No, that's not my hat. So it's like a.
Okay, so let's look at a couple of these. I'm going to show you with both methods. Okay? No more. We're good. Okay, so listen up. I'm going to show you with both methods. You okay, Tyler? Okay, I want you to listen to this, though, because I'm going to show you a method you might not have seen before. Okay? Okay, right now I'm going to draw both triangles. So you might want to draw them at the top of your page. The first one we're going to draw is the 45. So 1 root 2, and here's my 45, 45. What is it in radians? Pi over 4. You have to have those memorized. You have to have memorized that. I mean, you can convert, but that takes too much time. Honestly, memorize at 45 degrees is pi over 4. Memorize that 30 is pi over 6. And memorize that 60 is pi over 3. Okay? So you need to have those memorized. It's going to make things a lot easier and quicker. Okay, the last triangle I want to make. Now, which one's going to be my bigger angle, the bottom or the top? The bottom. So if this is our 60 is here and 30 is here. So what is 60 degrees as a radian? Pi over 3, and this is pi over 6, or 30. Okay? So how I like to memorize it is I actually am so used to radians. So I see pi over 3. Opposite of pi over 3 is root 3, 2, 1. Done. That's how I do it. Okay? Now, sine 120 degrees, which quadrant is that in? 2. So we have CAST, Will he be positive or negative? Positive. What's his reference angle? 60 degrees. So I'm actually going to calculate sine 60, positive sine 60. Okay? So looking at my right triangle, what's sine of 60 degrees? Root 3 over 2. Yes, Landon. Yeah. Okay. Now, if you used your unit circle, what would you do? Okay. You find 120 right here. Cos comma sine, it's root 3 over 2. That's it. Okay. So sine negative 2 pi over 3. Guys, when we have a negative angle, what do we want to do with it? Go backwards. Go to the positive. Figure out what it is as a positive. So how do I figure out what this is as a positive? If I have negative 2/3. Not multiply, no. If I want, this is the negative. If I want to figure out the positive version, we take our angle and we add 2 pi. So negative 2 pi over 3 plus 2 pi. Or as a fraction, if I want a common denominator, what 6 pi over 3 is 2 pi. So what is that angle equivalent to? So it's equal to 4 pi over 3. Now you'd have to do this whether it be unit circle method or you're using, right? You still have to figure out where negative 2 pi thirds is. Now, if I'm using my special triangles, what's the reference angle? It's very easy to see. We just look at the denominator. Well, if you're using the unit circle, you still have to figure out where's negative 2 pi over 3, right? So then you know it's equivalent to 4 pi thirds. Right? Now, looking at this guy, what's my reference angle if it's a 4 pi over 3? Yeah, you just look at the denominator. It'd be pi over 3. It's going to be pi over 3, pi over 6, or pi over 4. So we know we have pi over 3. In this quadrant, is he going to be a positive or a negative angle for sine? Positive or negative? Negative ratio, sorry, not angle. So this is equivalent to the negative sine of our reference angle. Because it's going to be a negative. So I'm going to figure out using my special triangles, and it's going to come out as a negative. So pi over 3, okay, pi over 3. And we want sine. So sine of pi over 3, what is that going to be? Root 3 over 2. And it'd be negative root 3 over 2 because of cast. Right? No. Yeah, I'm just saying this, sine 4 over 3, is equivalent to, because everything in the first quadrant is positive, so the negative of our reference angle. Right? Because they're the same, except for the sign changes. Yeah, right. So there's certain places that are the same ratio. So that's basically the concept we're using. Okay. The other method is using our negative root 3 over 2 is the ratio. So in our calculator, you can double check this. The question is to determine, rewrite the following functions as a function of their relative acute angles. So that's where I did here. That's this part, and then I evaluated it. So that's the question, and then I evaluated it. Yeah? I know it's equal to, because it's in this quadrant here, and sine's negative, it's equal to negative of the reference angle. If it was in this quadrant, it would be equivalent to the reference angle, and I'll show you with your unit circle. So here's pi over 3, here's pi over 3. So notice these guys are the same because of cast, right? Because of cast, same ratio, just negative sign. That's what we're using. Okay. And last guy, Should I go through this? Yeah. All right, so let's figure this one out. Guys, why is it negative? Because of cast.
What did we just find?
Okay, we found the equivalent acute ratio, acute angle. I know it's a lot. I realize. It's not positive. This would come out as a negative. If you type this into your calculator, this would come out a negative.
I don't understand. How did you go from sine pi over 3 to negative root 3 over 4?
Okay, so I use there's two ways you can do that. I use my special triangles. So sine of pi over 3 is opposite over hypotenuse.
Oh, okay.
Right? The other way, if you looked at pi over 3 on your unit circle, so this ratio right here, we are dealing with this angle here, right? So it's equivalent to sine pi over 3, negative sine pi over 3 as well. Okay? All right. So pi minus pi thirds, what is that equivalent to? 2 pi over 3. Okay? So if you think of this as 0 and this is pi, we want 2/3 of pi. Woo, right there. Generally speaking. Okay. So using cast, what, and we're dealing with cos, is cos going to be positive or negative? Negative. So we could say that our cos 2/3 is equivalent to the negative cos of our reference angle. Okay, we could say those are equivalent. Yeah, because it's 3 pi over 3. It's 2 pi over 3. Okay, so we can say these are now equivalent. If cos 2 pi thirds would be equivalent to the negative of our pi over 3. Cos pi over 3. Okay? So let's check it out. You can use your unit circle, or I'm going to use my special triangles. So cos of pi over 3 would be what? Cos of pi over 3. 1 over 2. So negative 1/2. Oops. I know. Okay? Now, this guy, what's 2 pi minus pi over 6? Go 12 over 6. 11 pi over 6. Okay, which quadrant will he land? The fourth quadrant. Thank you. 11 pi over 6, right? Because you're 2 pi minus pi over 6. Okay, so here's our 11 pi over 6. Now, we're dealing with the tan ratio. C-A-S-T. Will tan be positive or negative?
It's going to be negative.
Only cos is positive. So it's equivalent to negative tan pi over 6. You're getting it.
So if it was like cos that,
Yeah.
it's equivalent to cos pi over 6.
Right. Yeah. And if we wanted to evaluate it, I'm going to use this guy here. Tan pi over 6. Tan would be opposite over adjacent. So negative 1 over root 3, or negative root 3 over 3 if it's rationalized.
Like, no, I like get it now.
Yeah?
What the thing is, what this circle is.
Okay, so your homework's here. I'm good with working through some of it together with you if you feel like you need me to work through it with you. Okay, so the homework is here. Homework solutions, I will make sure it's on, I'll put it online right now so that they're up. And I'll work on uploading your marks too.